Hey, this is Ralph, and in this video I want to go over a solution demonstration for our assignment 8, solving problems with Excel. So this is a CIS 120 assignment, and I need to click in order to get the original Excel file. And let's see, I'll save this to my desktop. And I'll put a link to this video to this file in the video description so you can grab it from there too. All right, let's go ahead and open this up in Excel. And in theory, let's see, it's popped up over in my other screen. Cool. Enable editing, and there are several sheet tabs to work with down here. So this could take us a few minutes, but let's go ahead and figure it out. Now, the first one here is calculate a new hourly pay rate for each employee that is 10% higher than their existing pay rate. So this is going to just use some basic formulas to calculate the result. And if we do all of these properly, we shouldn't have to keep repeating ourselves. So we'll write it properly for the first person and then just autofill it down for the others. So we have the old pay rate, we need the new pay rate plus 10%. So let's do equals the old pay rate times 1.1, which is going to be, obviously if we multiply by 1, we get the exact same result. So multiplying at 1.1 is kind of like increasing 10%. And there we go, 2201. Autofill that down. Yeah, looks pretty good. All right, so that was pretty easy. Calculate the gain-loss percentage for each of the stocks based on different stock prices. All right, so when we want to calculate changes in prices or percentage changes, new minus the old divided by the old. So let's see, equals, I'm going to do this in parentheses, the newer price, even though it's 2021, the newer price minus the old price divided by the old price. Press enter. Now if we get a weird number like this, we're supposed to calculate the gain-loss percentage. So that's just a decimal format. We can easily format that as a percentage, and I'll show a decimal place. So now it's in percentage style, and that formula looks good. So I'll just autofill it all the way down. And what's nice about these, remember, you can test them out pretty easy. We could take something, maybe we had something that was $100 and it changed to $50. Well, that was a decrease of 50%. All right, makes sense. What if it was $100 and went up to $200? Well, that was an increase of 100%. I think that takes care of the first result. Now remember, when I grade these, by the way, too, I don't have to go and look at each formula. Typically what I'll do is I'll just click on, I'll download your worksheet, I'll just click on that first one and I just autofill it down and I just look for what looks proper. And that's usually the obvious sign right there that it's working and everything was calculated. So I'll just click on the first one, autofill it down, and then I move on to the next one. Now this one's going to require a little bit of thinking. We have 4 scenarios, and I want you to use Excel in order to tell me which deal is better, which means there's going to have to be a couple of different formulas here. So and you have to prove it. So what's the better deal? A computer that's $1,050 that is 15% off, or a computer that's $1,100 with $200 off coupon? We need to use some formulas to figure out which one's the better deal, and then I want you to highlight the better one in some obvious way. There we go. Background fill color for the best answer to green. Cool. All right, well, let's figure this out. If a computer is $1,050 and it's 15% off, and there's a couple ways we could write this, by the way, but what if I just take 1050 and I multiply that by 0.85, which is 85% of 100. 100 minus 15% is 85. That's going to let me know that this computer A is $892.50. Don't need to format it as currency or anything unless you just want to. All right, well, that's true. Let's try computer B. That's going to equal 1100 minus 200. I know you can do the math in your head, but I want you to use Excel and prove it. Show your work. 1100 minus 200, that computer is $900, so clearly computer A is the better deal, and I will change that to a dark green font, and let's change the fill to a light green, and let's make it bold and a little bit bigger. You know what, I'm going to do a little vertical centering on both of these. I think that looks a little nicer. But at least now it'll be clear. So when I get your worksheet, I'll be able to click on that green cell to see that you put in some math in order to figure out which the better deal was. So computer A is the better deal for us. Okay, which job pay is the best deal? A job paying $29 per hour for 40 hours per week, or a job paying 58 grand per year? All right, well, let's figure this out. Let's put it in common terms, of course. So my job A is going to be equal to 29 times 40 hours per week times, well, how many weeks per year? Do you do 50 or 52? Yeah, most people just might do 52. So let's figure that out. Okay, so that's 60,320, and of course a job paying 58 grand per year, nothing to factor in there. What if we only multiplied it by 50? Let's say there was 2 weeks that we don't get paid for vacation or something like that. They come out about equal there. Interesting. Okay, but there are 52 weeks in a year, so we'll put that back to 52. And so definitely this would be the slight, assuming all other things are equal, that would be the better job. So I'm just going to copy the formatting from that other correct one right there. A job paying $58,000 a year equals 58,000. And we'll just format paint. And there we go. So the better job in this scenario is job A. Did I do that right? Yeah, 29 bucks an hour times 40 hours per week times 52 weeks per year gets it into an annual salary range. All right, looks pretty good. All right, let's jump over here. Which of the following hiking boots is the best deal? So we've got some $110 boots that are rated for 1,400 miles, $180 boots that are rated for 2,600 miles. All right. Equals 110 divided by 1,400. That's going to get us a number here. And let's go ahead and style both of these. So we could assume, in fact, let's go ahead and put them in currency format. Let's do currency and let's show a couple extra decimals here. So we're looking at something like 7.86 cents. All right. And let's try the other one. Equals 180 divided by 2,600. So we have 0.07 and 0.069. So we can start to assume that that's going to be the price per mile. So 0.06 cents per mile, or $0.06 per mile, so 6 cents per mile. Looks like this one's going to be the better deal. So let's go ahead and format. Well, I'll just do green fill, bold, and a little bit bigger. So that one stands out. All right, so it looks like Boots B was the better deal. Which gym membership is the best deal? $50 sign-up fee, then $19 a month for 2 years, or no sign-up fee, but $20.99 per month for 2 years. Okay, so this formula is going to be equal to 50 plus, and I'm going to do a little parentheses here, 19 times 24 months over 2 years. All right, we got that number, $506 versus 20.99 times 24 months for 2 years, 503. All right, let's go ahead and style both of those so that they are vertically centered. And since the better deal is going to be cheaper for us, this one with no sign-up fee and this higher monthly rate is the better deal. And so let's go ahead and format that one. Cool. And I'll get rid of a couple decimal places. So it looks like gym membership deal B was the better way to go. All right, I think that's pretty good. So let's move on to this one here. Payment functions. We've practiced payment functions a couple times with some different assignments. So you should be able to fly through this one pretty well. However, this weekly payment one sometimes throws people. So let's see how we do. First one is a car payment, then we're going to do a mortgage payment, and then credit card payment calculator. The good news is it's basically the same payment function. So let's try this. And we'll go kind of fast here. Equals PMT, the rate, annual rate, divided by 12 to get a monthly rate, comma, number of periods. This is already in months, so the cell that contains the number of months, comma, present value is going to be the loan amount. Ooh, I forgot to calculate the loan amount, so I got to do that. But I'm going to do a negative version of the cell that's going to contain the loan amount. Close that out, and then I got to do some math here. It looks like equals the price of the car minus the down payment is going to give me that loan amount. Payment is just under $500. What's the total paid? Total paid is going to be equal to the monthly payment times the number of months I paid it plus the down payment. That's the total paid, $37,000, about $800, $37,800. Finance cost is going to be equal to the total paid minus the original price of the car. Price of the car was 34 grand. We paid about 38 grand. We paid almost 4,000 extra because we financed. There we go. That's the first one. It's going to be pretty similar for these others. You know what? I wonder, could we copy and paste? Let's find out. I'm going to copy all of that and paste it over. And okay, so we know we're going to have to fix some stuff, right? I got to get that loan amount in there. Let's try that one. Copy that, paste, and there we go. Okay, we're definitely going to have to fix this. And this probably bothers me the most of anything is when you turn in work and it's just way wacky. So if you see that this house payment was calculated at $8,700 per month, the alert should go off. You may not know what the problem is, but you should definitely know that there's a problem. So if this happens to you, don't turn your work in assuming it's done and, hey, it's all ready to get graded. No. If you're not sure what's going on, send me an email. Say, hey, Ralph, I know there's something a little bit off with this formula because my house payment is coming out to almost $9 grand a month. I know there's something up with it, but I don't know what. That gives us some room to work. Okay, so let's figure out what is wrong with this. Now the rate, annual rate divided by 12, that looks good. Number of periods, though, it's calculating for 30 years. So basically, it's doing annual payments. We need to take those years and multiply it by 12 to get the number of months. And then we have, for the present value, as a negative version of the loan amount. That looks good. I'm clicking on these little arguments, which highlights parts of the function. And then I'm also letting the color coding that it does for me to alert my eye to what's going on there. So I can see E4 is purple. That's the loan amount. That looks good. So really, the only thing we had to do, we had to get those number of payment periods into monthly terms. That gets the mortgage payment down to $1,200, which is much more realistic. Total paid doesn't seem right, so let's fix that. If your total paid is ever less than the price of the thing, then you know something is messed up. So the total paid, let's see, we've got E7, which is the monthly payment, times E5, the number of years, times 12 months per year. Got to get that in there. $474 for the $300,000 house. That's better. That one looks much more accurate. Okay, so yeah, go with what's realistic. Now, let's do this for a credit card payment. Monthly payment is going to be equal to my credit card annual rate divided by 12, comma, the number of months, comma, and then for the loan amount for a credit card, there's no down payment, so we just click, let's do a negative version of that credit card payment or credit card debt. There's our monthly payment equals the total paid is going to be the monthly payment times the number of months we paid it. Once again, no down payment to deal with. There we go. So we borrow on a credit card $11,000 worth of stuff. We end up having to pay back over 4 years $14,600. So the finance cost, because we used a credit card instead of cash, we had to do total paid minus the original credit card borrowing amount. There we go. Now, of course, this is only accurate if you stop using that credit card. Otherwise, you're going to keep adding to the balance and stuff. There we go. Credit card payment calculator again. However, this one is weekly payments. Weekly payments. Let's see how that's different. Equals PMT. The rate, I'm going to take the annual rate and I'm going to divide it by 52, number of weeks per year, comma, number of periods, 30 months. This is where it gets a little bit tricky, right? How many weeks are in a month? It would be inappropriate for us to do times 4 because there's a little bit more, for most months, there's a little bit more than 4 weeks per year, or 4 weeks per month. So what's going to be the best number that we can put in, at least to get us reasonably accurate here? Well, let's see. What if we did something like, how many years would this be? Well, if we did 30 divided by 12, 30 months divided by 12 months, we're going to get the number of years. And if we multiply that by 52 weeks per year, that would give us the number of weeks. I know that seems a little bit weird, so let's think about this for a moment. I'll just escape out of that for a second. So I'm just going to do a little math off to the side here. Let's see, we've got months, years, weeks. Let's assume our months is 30 and then equals, how many years is that? So let's take equals the number of months divided by 12. That looks accurate, right? 30 months, 2.5 years, makes sense. 12 months, 2 years, 24 months, plus another 6. 6 is half of 12, 2.5, that looks good. Equals, and let's take the number of years and multiply that by 52. So basically, 30 months is equivalent to 130 weeks. All right, well, that seems pretty reasonable. Let's test it out. Let's do 1 month. 1 month is about 4.33 weeks. That also sounds pretty good. So at least that lets us know that that formula is correct. So let's head back over here to this weekly payment equals PMT. The rate is right there, divided by 52 to get 52, get that annual rate converted into weekly terms, comma, number of periods. Let's take the number of months divided by 12, which is going to give us the number of years, multiplied by 52 to get the number of weeks. We could have also factored in that 4.33 in there somewhere too. Comma, present value is going to be a negative version of the credit card debt. I think everything else is good. Got the weeks, yep. And I must have forgotten I forgot my closing parentheses there. It looks like Excel is going to help me out though and put it in for me. Cool. So the weekly payment of $69.18, that sounds pretty realistic. Let's find out though. Total paid is equal to my weekly payment times number of months times, this time I'll do 4.33. So months times 4.33 should be a pretty good approximation of the number of weeks for that 30 months. Okay, 89, 87, that sounds pretty good because we know the total paid is going to be a little bit higher than the original credit card debt and of course the finance cost. And I'll just copy that one and paste it over. There we go. All right, that looks pretty good. So a little bit trickier when we convert these normal monthly values into weeks, but I'm pretty happy with that one. All right, we're moving on to exercise 4, saving money. All right, we've got 2 scenarios here. All right, Sarah and Selena. They are both 22 years old. All right, here's the deal with this one. So Sarah is going to wait to invest, and then she's going to invest $2,400 per year until retirement. Whereas Selena, she's going to invest $2,400 a year right away, but only do it for like 10 years, and then she's just going to just sit on it for a bit and see how much we have at retirement. Now, of course, it's a 50-50 shot. You could guess at which one's going to be better off, but we want to use Excel to prove the case. So let's see what we've got going on here. Both are expecting an average 10%, so it's a word problem. All right, so we got 10%. You know what I'm going to do? I'm just going to type a 10% right here so that I can reference it really easy with my formulas, and then I can change that number if I want to just to see what happens. And okay, let's give it a shot. And this is in years. Notice it's in years, so that should be pretty easy for us to figure out. So at the end of the first year, how much is Sarah going to have? Well, it's going to be equal to her investment. And I'm going to try not to type in too many hard numbers so that way it makes it easy for us to autofill down and also easy for us to change values and see how that works. So the first balance is going to be equal to her investment, which of course is 0. The next balance is going to be equal to her previous balance plus her latest investment. However, I also need to factor in the return rate, right? 10% per year. So let's see. Her previous investment, check this out. I'm going to put that, in fact, I'll put this in parentheses. I'm going to take her previous balance times, another parentheses, 1 plus the cell that contains that interest rate. Closing parentheses, closing parentheses. What the hell am I doing here? Okay, now remember on that percentage increase where I multiplied by 1.1 in order to show that 10% increase? That's exactly what I'm doing here. So basically I'm taking the previous balance, doesn't matter that it's 0 by the way, and I'm multiplying that by 1 plus whatever is in I-10. I-10 is 10%, which is 0.1. 1 plus 0.1 is 1.1. So I'm taking her previous balance, multiplying it by 1.1, plus I'm adding in the latest investment. All right, let's see how that looks. Of course, it's zeros. However, you know what? Let's make this absolute reference. I-10, my Windows machine, F4, make that an absolute reference, since all of my formulas are going to reference that 10% cell. I'm going to autofill it down. I should just be able to double click on that fill handle, and let's see how it looks. So finally she starts investing. All right, $2,400. Now, the way I'm calculating this, it looks like she's putting the $2,400 at the end of the year, because after her first one, there's no 10% added. All right, fair enough. And then we do 2,400 plus 2,400. Now she's going to get 10% of that 2,400. 10% of 2,400 is about $240. So that takes us to what? 2,640. And 2,640 plus another 2,400 at the end of the year gets us to 5,040. So that looks like it's accurate. Which means at retirement, the little format painter, Sarah is going to have just under 600K. Cool. All right, but she has to invest. Oh, I should really sum all those up, all that investment. Be kind of curious to see what that is. Equals sum. Let's add up all of that. Little format painter there. Cool. Okay, so Sarah had to invest 81 grand in order to get to that 600 grand or 590 at retirement. All right, but now that we have that technique down, let's try it again. This time equals the investment. So again, we're pretending these ladies are investing their money at the end of the year. So at the end of the first year, Selena invests $2,400. Her balance is $2,400. She invested right at the end, let's say December 30th or something like that, whatever the last Friday was. So we're not getting any interest on that first year. However, again, I could be copying this formula over, of course, but let's type it again to make sure we've got it. Equals the parentheses, previous balance times parentheses 1 plus my interest rate, absolute, closing parentheses, and then closing parentheses, plus, and then I can't click on that cell, so I'll just have to look. It's L14. Okay, so we have the previous year's balance plus plus the interest from that first year, because now we're at the end of year 2, plus the investment again at the end of that year. And yeah, the math works out right because we tested it before. Yeah, after 1 year of 10% interest on $2,400 plus another $2,400 on top of that, 50/40, that looks good. Let's just autofill that all the way down. And let's see what we get here. Just under $1 million, 980 grand. I'm going to do a little bit of, actually, let's copy this formula, this sum formula over. That looks right, and let's make sure we just do a little format painter action going on. Excellent. So here's the scenario. We have Sarah, who invested 81 grand over a bunch of years, and she got to less than 600,000, where Selena invests. Oops, I put the sum in the wrong spot. So let me cut that. Paste it right there. There we go. Selena invests a little over 10 grand. Look at that. So 1/8 of the that doesn't look very good, does it? Look at my my calculation. It's like 10 million. Let's see what happens here. Sum. Let's get this proper. Let's go ahead and select all of those. Remember, if those numbers look out of whack, let it draw your attention. That makes sense, right? She's investing $2,400 a year for 10 years. Therefore, she invested 24 grand, so about 1/4, 1/3 of Sarah's investment, and she gets more money. All right, so all this little exercise is hopefully pointing out to you is that the investment amount obviously is important, but not nearly as important as starting early. Starting early, and obviously 2,400 a year is a pretty good amount. Obviously being young helps. So first rule, be young. Second rule, start right away. Start today at your investing. Step 3, do it for as long as you can until you retire. All right, so that's what that takes care of. That's exercise 4. Finally, we can jump over to exercise 5, which looks a lot like car payments, but it is different. This is going to be future value calculations. Again, we've practiced these in a previous week, so now you're just really solidifying that you know how to do an FV function. All right, let's get to work. Years left to retirement for the first one. Let's take our goal retirement age minus our current age, gets the number of years left. Future value equals FV, parentheses, the rate, annual rate, divided by 12 to get monthly rate, comma, number of periods, years left, times 12 to get the number of months left, comma. Payment is going to be a negative version of the monthly investment. There we go. 25-year-old is going to retire at 66. They have 41 years left. That's a huge time horizon. That's great. Monthly investment, $300 a month. They're going to average an annual return of 11%. That's actually pretty realistic. Last 50 years of the S&P 500 has averaged 11%. Future value, $2.8 million. Awesome. Great. All right, that looks pretty good. Let's try it again. Calculator 2 equals retirement age is only 55 minus the current age of 18. Looks good. They have a 37-year time horizon. They're going to invest $150 a month. They're expecting a 10% rate of return, a little more conservative value there. Future value equals FV parentheses, the rate, again, annual rate, divided by 12 to get into the monthly terms. Number of periods is going to be the number of years left, times 12, monthly terms, comma, negative version of that monthly investment. Money that you pay out leaves you. It's a negative. Money you receive at the end is a positive. Closing parentheses, enter. Look at the big difference, though. Now, this person only had 37 years instead of 41, but there's also, they're only investing $150 a month instead of $300, and they're expecting a 10% return instead of an 11% return. So $2.8 million instead of $700,000. So definitely you want to build that up. Of course, when you're 18, it's tough to come up with the scratch to invest that much per month. So let's assume in real life that by the time this person is 20 and 22, they'll be saving $150, then $250 and $350 a month. And by the time they get into their upper 20s and 30s, they'll be investing even more. Okay, let's keep it going here. Now, these are weekly investments, so let's figure these out. Years left, well, these are going to be easy, so I'm just going to take my years left up here, copy that, paste, and those are going to be accurate. 39-year time horizon, 32-year time horizon. Let's get to work. Both of these are weekly, so I should just be able to do one, right? Equals, let's see, future value. The rate is going to be my annual rate divided by 52 weeks per year, comma. Number of periods is years left, times 52, comma. Payment is negative weekly investment. Closing parentheses, press enter, perfect. Now, this seems like a pretty big deal. This number is not out of whack, it's just big. Because remember, this person still has a big time horizon. 39 years is huge. But they're investing $200 per week, weekly compounding. They're also expecting 11% annual return. $200 a week is obviously more than $800 a month, because we know a month there's like 4.33 weeks per year or per month. So that's a pretty big savings, $200 per week. So yeah, 6.7 million. And yeah, so that's accurate. Technically, I think we could take this, copy that, paste it over. Yeah, that's probably accurate. And cool. So weekly investment is a little bit less, time horizon's a little bit less, and of course they have a pretty big difference in that future value. All right. So I think that takes care of our future value calculators. By the way, if I'm looking at this, I can't tell that you copied and pasted a formula. So it's okay if you do that. However, always double check to make sure those formulas are accurate for those new cells. I think that's good. So you would save this and you would turn this in via Blackboard. I don't know where my Blackboard is. There it is. Just save that, turn that Excel file right in there. And I saw one of your classmates just contacted me in Teams, so I'm going to go check that out. See ya.